I think so.
We can't hear you clearly, Ravindra. Yeah, right now clearly we can hear.
Uh, this is so great. Lemon. We have this is number one. Number one, we have these so like I told we have four books. And that means these eight now and it is the area
Mr. Ravindra, I think still there is it's not clear. I think it's because of the headset, I think.
If is it okay now? Okay, Sudhir, can you hear me now clearly?
Yes, now it's better.
Okay. Sorry. So, in the part two book, we have these lessons. So, this is for your term test two, basically percentages, share marker, the midpoint theorem, graphs, equation, equiangle triangles, data representation, geometric progression. So, basically, if I show you the proper oral paper, you can see what are the questions they are based on. So mostly from like 70 to 80% based on grade 10 syllabus and like 20 to 30% based on grade 11 syllabus. So, but there are some parts which are like if we take like algebra, in binomial expression and everything, in grade 11 syllabus, they are more focused on the deep things. So
Then
I'll just show you in here. This is our oral paper, which is done in 2023-24. And we have this kind of book. This is part A. So this is Mathematics 1, part A. In part A, in normal papers, we have MCQ like stuff. No? Now here we have something to work on. So we have here, there are some questions based on all the lessons you learned, and there are 25 questions. After that, you have in the mathematics one, you have part B book, which has 5 questions. Okay, you have to show these with workings, proper workings. After that, you have mathematics 2, and in here you can choose some questions. Like in mathematics second paper, part 2 paper, you have part A and part B. In part A, you can choose 5 questions from 6. So after 10 questions, selecting 5 questions from part A and 5 questions from part B. So there are 6 questions. From these 6 questions, you can just choose 5 of them, which you are confident enough. So at the end of this class, I hope to do these kind of question papers with you. So we'll see. So we'll start this first lesson in our grade level syllabus. That is real numbers. Okay, so I'll share my other screen.
හැමෝම ටැවිලු ගන්න අය මම හිතන්නේ.
So what are real numbers? So real numbers are, first I want to discuss what are integers. What are integers? So integers are the things, integers are the numbers, the collection of the whole numbers, including negative 0, negative numbers, 0 and positive numbers. That means consider all the counting numbers. So counting numbers can be start from 1, 2, 3, 4, 5, and it goes to infinity. Positive infinity. This side is positive. So, and also there's something 0. And you can go to negative infinity. That is -1, -2, -3, and so on. So in these things, you can consider 0 and positive numbers as well as negative numbers. Those are called as integers. And we are showing it with a specific symbol. Like this. So it is called integers. Now remember this one. So integers contain negative numbers, 0 and positive numbers. So on we are going to learn about different things. So in that case, I'm just write this here as integers, the symbol. So then if I show my, so if I tell you other thing we are going to learn about is natural numbers. So natural numbers. So natural numbers, we show it with a symbol like this. It's just an N, and also there's a small line like this. Okay. It's something like N, something like this. I'll show you. It's better you go with the symbols also, because in some cases they will ask you with the symbol. So I'll just put the symbol here. So set of integers with symbol of z, and those are counting numbers including 0 and negative numbers and positive numbers. So and here if there's something like z and plus, that means that set, here these curly bracket we show the set. So that set contains only positive integer. If the symbol with minus value shows it goes minus negative integers, and so on. So it can be positive or negative integers, as well as if you consider the whole set of integers, it contains 0. Okay. So this next one is the set of natural numbers, and it is shown by this symbol. The n symbol. In natural numbers are the counting numbers. So if I just write it like this, n natural numbers are set of counting numbers. 1, 2, 3, 4, 5. Okay. So natural numbers are positive whole numbers. So they are positive whole numbers. Okay. So they are used to count objects. Okay. So we are basically from grade 1 to until now, we are working with natural numbers. And here the thing is 0 is not included in this natural number. Okay. So in integers, we have zeros, positive integers, negative integers, plus 0. It is called as set of integers. Okay. Then natural numbers, you have only counted numbers from positive counted numbers, positive whole numbers from 1 to infinity. So this is natural numbers. Then we are going to learn about rational numbers. Rational numbers. So I'll just show you the symbol rational numbers. So if you are familiar with rational numbers, we are going to use the symbol Q. So rational numbers, the set of rational numbers is a collection of all the numbers that can be written as fractions. All the numbers that can be written as fractions. Okay, Q. There's a small line like this. Okay. So if I just write something like this, if you consider fraction a over b, okay, and we are saying a and b, a and b are integers. Integers are counting numbers, but b is not equal to 0. B is not equal to 0. So if it is becomes 0, think as like this, 2 over, if you put 0, this will goes to infinity. The value is not equal to 0. If you divide 0 by any number, it is equal to 0. But if you divide any number by 0, it goes to infinity. So that is the rational number. To make rational number, b cannot be 0. So we are writing it like this. A and b are integers, but b is not a 0. So rational number is a ratio of two integers. It's a ratio of two integers. And the denominator, that means this one, the down one, denominator cannot be 0. So if I just write any number like this, half is a rational number. -3/4, -5/6. Okay, these are rational numbers. Okay, so even a 0/1 is a rational number. So the thing is, there is another thing called if you can just note it down, these things. Rational numbers are the things A or B and A and B are integers, but B is not equal to 0. So you can note it down. So and other thing is, in rational numbers there are something called terminating decimal. Terminating decimals. I'll use a different color. In terminating decimals mean think like this. If you just divide 10 by 2 is equal to 5. Okay. Or if you just divide 1/2, that will make you a decimal number. Okay. So that should goes here. Okay. A terminating decimal. That means the value is like it will be over, the decimal value will be over within few decimals. Think like any number which has 0.125, 0.575. If you end with these numbers and you don't have any value here, then these are belongs to terminating decimal. If something has something like this, I think you seen these things 0.3333333. These are also called recurring decimals. Recurring decimals. Okay. Or else we just show it like this. We put a small dot on top, right? We put a small dot on top to show it. This is a recurring decimal. So these are, but recurring decimals are not rational numbers. These are not rational numbers. Okay. Rational numbers are the things you have a terminating decimal. Okay, so other ones are not rational number. The repeating decimals, these are recurring numbers. Those are not rational numbers. And so I'll just show you other part, which is irrational number. So this is the symbol for the irrational numbers. Which is a Q complement. So you heard about complement? It's like that. Without Q, like that. So irrational numbers, if I just tell you irrational numbers, the set of irrational numbers is a collection of numbers that cannot be written as a fraction of two integers. So if I just tell you like this, Q, numbers cannot be expressed as fractions, basically. So if I just tell you about something of root 2, if I just put root 2 or pi, the symbol you know pi, we are using 22/7, which is to make our work easier. But pi has a value which is like it divisible, and still they are counting on it. Like still they have not done it yet. So if you just write pi we can say pi is equal to 3.142, but it's not. These numbers are still dividing and going. It is like 8, 5, 7, 1, 4, 2, 9, and 4. And the thing is, these numbers does not contain any recurring format. It is not repeating. Here, can you see any repeat number? Nope. These numbers are not repeating. These numbers does not have a pattern. It will go. Okay. So in the book it says there is no specific symbol to denote the set of irrational number that is usually denoted by q dash. The complement of the set, or q complement, this is for complement, the q complement, the numbers root 2, root 3, root 5 can be given as examples of irrational numbers. In fact, the square root of any positive mathematician, positive integers, which is not perfect square, is a rational number. If I just show you what is a perfect square, if you just put 4 inside of a square root, you can get number 2. Number 2, if I can just put number 16 inside of a perfect square, sorry, square root, it will give you 4. So those are perfect numbers. They are telling not these numbers. If you put any other number in front inside square root, you will get an irrational number. So irrational numbers are shown by q complement. Then we are going to learn about real numbers. So we'll see what are real numbers. So before that, I'll just show you this is the real number. Right. So the real numbers, the set of real numbers is a collection of all rational and irrational numbers. That means it's like R with a line. Okay, those are combination of rational and irrational numbers. Basically, Q and Q complement they are talking about, right? Q and Q complement. So in this real numbers, in these real numbers, this contains what? Natural numbers. It contains natural numbers. Why? You can have 1, 2, 3, 4, all the positive integers, and all the whole numbers. All the whole numbers like 0, 1, 2, 3, 4, so on. And if you just add these together, like all these things, we can say integers. We can say it goes minus infinity and comes back -5, -4, -3, -2, -1, 0, 1, 2, 3, and goes to plus infinity. We can say integers also. And it includes rational numbers. All the Q's. And it contains irrational numbers. All the square root values, and pi, something that is not divisible. And rational numbers, we can say fractions. Okay, like that. Okay, so these everything contains in the set of real numbers. So far you learned about integers, set of natural numbers, set of rational numbers, irrational numbers, and real numbers. Now we can put this into one diagram. What this diagram is. in the grade 11 book, you have a pretty good okay. Now, as you can see, this is what I explained so far. If you just look at here, you have all the positive integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, everything. Here you have contained -1, -2, -3, -4, -5, plus including the 0. Then this set belongs to our integer set, not negative integer, it is integer set. So we can either say like this. This is set of negative integers and this is set of what is positive integers. So -3, -2, -1, 1, 2, 3. And if you put 0, the whole set I can say it as not integers, right? So you can say this is minus negative integers, this is positive integers, or you can see, you can say it including the 0, this is set of integers, okay? And again, we have rational numbers. So rational numbers, I told you, are numbers, a fraction, a numbers which can be divisible. Okay, the thing number 5, we can write it as a fraction. Where the 1 is the invisible number. We don't write any number below this 5. No? But remember, you have a number. Even take 10, it has a number. And 15 has a number. Now everybody is talking about 6 and 7. It also have a number, right? Everything has a number like so. Those numbers are look now. These numbers, if I just write 5 is actually we can write it inside here also. Then if you forget this 5, so that means it is inside the real set. So rational number set. Rational number set is 5. That means integers is positive integers is inside rational numbers. That means all the positive integers or else negative integers, we can say it is belong to the rational number set. Okay, and those things that I told you, which has that infinity numbers, that means it is not repeating. It does not have pattern. It goes to, I don't know. It still go in those numbers. Okay, so in that case, we call those irrational numbers. So we write as Q complement. All these things are belongs to real number set, right? Real number set. Okay. Now I am going to tell you something more than what you are learning in grade 11, because if you are thinking to go to grade A levels and A levels, if you're thinking to go to like mathematics streams, combined math streams, in that case you are going to learn about something more than this, like what is a part of these things. Okay, a part of this one, there is something called not this. We have real numbers and there should be some values. Think like this. Now you can you can find the square root of 4 and it will give you 2. I'll just use my calculator also. If you just put square root 8, it will show like 2.828 like this. If you can see it clearly, you can't see it. So it's something like that. Now what happens if you put a minus value inside? Or you just take root 4. If we just take minus 4, what will be the answer? Actually, it is not minus 2. You can't because this minus 2 into minus 2 makes a plus 4. If you just divide it, sorry, if you square root it, you will end up with getting plus or minus 2, either plus or minus 2. We are always in square root a positive integer, positive value, and it will give you a minus or a positive integer into itself. That is what we are going to learn in the next subtopic, thirds. So in here, what is this minus 4 means? So how do we show this? In the A-level syllabus, you learn about something called imaginary numbers. Imaginary numbers. Or we'll show it as I. So in that case, if you just take the previous one minus 4, we can write it as 4 minus 1. 4 minus 1. We just took minus 1 out of minus 4. Then we wrote it like this. And we know minus 4, we can write it as 2, right? Sorry, plus 4, square root of 4, we can write it as like this. Or we can write this like this. Root 4 times minus I and minus 1. This 4 becomes 2, and this minus 1, square root minus 1 becomes I. Okay. This is for your A levels, and there is something called imaginary numbers also. Okay, remember. Then we are going to learn about thirds. That what we started right now. Square roots. We are calling this as roots. So in root, we'll just take a new window. Okay. So in the second subtopic, we are going to learn about thirds. Thirds. So what is this? What are these thirds? Thirds are the numbers that contain root. What is a root? Root is this one. So it contains a root. It can be square root. What is square root means? If you just put like this, it's a square root. If you just put like this and put 3 here, that is cube root. We call this as cube root. Okay. And this one, root of 4, root of 5. So just like that. This is in the small pocket. Okay, remember we are just going to put small pocket. We don't write it here. It is in the square root. You always know you are just finding the square of it. So you don't need to put it here. In the cube root, in the small pocket, you will put it something like this. Then this becomes the cube root. I'll explain how to find the cube root, square root, everything. As a definition, we'll just write like this, thirds. So you can note it down if you want to. I'll just write the explanation of the thirds. Thirds is irrational. Where value third is irrational number written in root form, where the value under the root sign is not a perfect square. So that means square root 8 is not a perfect square, but square root 16 is. Square root 16 is, answer is 4. Square root of 25 is 5. So that means these are perfect squares. Where the values under the root sign is not a perfect square, then it will become a third. It becomes a third. So if you want, you can just write this down. I'll give you some more time. Okay, so here now we are going to learn some examples, and I'm going to give you some exercise. Then we'll just do it. I'll give you some time. After that, I'll explain how to do those things, and we'll write the answer. And all the attachments are I attached it to the website also. You can download the attachment. Those are exercises, as well as I'll put some exam practice questions also. So search. We'll do some exam. I'll just take. Now, simplify 3 root 5 and 6 root 5. Okay. So here you can see the inside root, you don't have a perfect square number. Root 5 is not a perfect square. But as you can see, outside you have a number. So we can keep this as something called entire third. That means the whole thing is a third. That means the entire thing is a third. This is not an entire third. What is the entire third? Entire third is things like this. You have square root 20. So a special feature of a third of the form of square root 20 is that the whole number is under the radical sign. That means the root sign. Such thirds are defined as entire thirds. These are called entire thirds. That means you don't have any numbers in front, or these are not attached to anything, just a square root number, which is not a perfect square number also either. Inside this one is not a perfect square number. So we call these as entire thirds. Okay, entire thirds. So if you have any questions, you can ask me just through raising your hand or typing in message in the chat. So here, now think like this. How to turn this entire third into a third which contains like this, a rational number and irrational number. It's like this. A third, and this is a third and rational number. See, if we just take 20, we can write it as 4 times 5, right? So you have to put the square root inside the same. 20, we can write it as 4 times 5. But you know, 4 is a perfect number, but 5 is not. 5 is not a perfect number. So then this root 4 applies to this root is applies to 4 and it becomes 2, and this root 5 comes. Okay, this is not an entire third. This is a third and a rational number. Okay, so sometimes they will ask you to write this as entire third. If they ask you to write this in entire third, remember you have to make it like this. Otherwise, if you keep the answer like this, you won't get the full marks. Okay, and especially these thirds are not a thing like in a whole question. Third is not a whole question. These are parts of the question. As example, can you remember in grade 10 you learned about something called binomial expression? In binomial expressions, you have drawings are bad. You can remember this, I think. It is in first term or something to learn this first term. In here, if you just put x and this is value of 12, and here you put x and this is value of 13. Okay? If they ask you what is the area of this the rectangular shaped thing, you can say it as x plus 12 into x plus 13, right? Then you multiply these and these and these, and you'll get an answer with x squared, something. So just like this, it can be square roots. Then you are multiplying square roots and thirds, and there will be some thirds value, some square root values. Okay. So those third lesson can be applied there in area as well as volume, algebra. Those areas you can just they can ask you third, but third they can't ask you a direct whole question in a part mathematics 2 paper. So remember that. So if they ask you to write it in the entire third, so remember to write the it as a fully third, entire third. We'll do some question, then you'll realize what they are asking. So in here, we'll just so we'll go to the first question, our first example. It is 3 root 5 plus 6 root 5. Remember, we have same root signs, same third here. Okay, same third. It's like same base. Can you remember in indices? We have 2 to the power 3 into 2 to the power 5. In indices, we have something like this. You have indices value different, but the base value, we call this as base. Same base. If you have the same base, we can do what? Add these two. Add these. Here, if you can answer or if you have any question, ask me. Okay. So we can just write it as 2 to the power 8, something like this. Okay. So in here, thirds also. In thirds also, we can do the same. How? You call this as same thirds of root 5, root 5. So consider this as just a value, okay, and add these two. 6, 3 and 6, it will be 9. Answer will be 9 square root 5. Okay. So if they ask you to keep this in the entire third, then how to turn this into entire third? So I'll just give you a moment to realize how you just convert this. Well, I'll just here now there's root 5 and 9. If they want to find this in entire terms, what we are going to do is we are going to pair this 9 and put that inside the square. It will be 81 times 5. So this is what the entire third is, and it will give square root 405. And this is our entire third. If they ask you to write in thirds only, you can write it, keep it like this, 9 square root 5. If they ask you to write it in entire third, then you have to multiply this number by itself and put that inside the square root and multiply the number of the third. Then you will get something like this. Then I'll give you another example. Now this is how they ask. Express the entire third root 20 as a third. See, this is what I'm talking about. This is the entire third, no? Express this entire third as a third. Third means it can be like 2 root 10, 5 root 4, something like that. Okay. So this you can't. 4 is a square number square. So how do you do this? Here, first thing is you have to find the factors of 20. So n, this is 2, 4, 5, 10, 20. Okay. Those are the factors now. So in that case, look what numbers can multiply each other and make a 20. 4 and 5, right? If you just take 10 and 2, this won't make a third. I'll show you why. In here, you can see 4. We learned this is a perfect square number. But can you see any perfect square numbers here? 10 times 2? Yes, basically it makes 20, right? 10 times 2 basically makes 20. But this does not contain a perfect square number. Maybe. So in that case, we have to write the thirds in the form of a perfect square number inside. So we'll take this one. When you put a square root like this, you can write it like this also. 4 times square root 5. Now you know the square root 4 makes 2. And square root 5, you can write it as like this. This is the third. This is the third. So remember, if you just have something like this, you can write it as like this. So if there's two values, a is to be, sorry, ab, we can write it as square root a times square root b. These two values are outside, okay? These two values are outside. Now, if you can copy this down quickly. Okay, then I'm going to do another example before we are going to do some exercise. So this example, they are asking you to express the third, this third as an entire third. We did this before. How do we do this? So first take the third like this. We have 4, we have square root 5. They are asking to make this as an entire third. I'll give 1 minute. Try to do this quickly. Here, okay, I'll show you how to do this. Just like I told you before, take the 4 and multiply by itself and multiply the third number. Let me put this inside. Sorry. Okay. You have to multiply the third number, the integer, and you have to multiply the number by itself and the third value. This can give you as 16, right? 4 times 4 is 16 times 5, right? So what is 16 times 5? You get 80. So this is the set. This is the entire. This is the answer of the entire set. So you, for what you did first, you just multiply the number by itself, and then you multiply it by the third number. Then you are getting 16 or whatever the number they are asking, and then you have to multiply and get the entire third value. You can copy this down. Okay. Now we are going to learn about another example of search. That is multiplication. So here you have search with two base, two different base. Can't call base, a default search. So what happens? But remember, this is not addition. Previously, what there was, it's like 3, 6, right? There was positive, sorry, addition. That means you have to add these two surds. So if it is in same surd format, you can add and write like this. But what happens if you have two different surds value and it is multiplication? This is can be done like this. You can write it like this. Equals to, I just take the coefficient. We call this as coefficient. The number in front of something we call coefficient. So we can write it like this: 5 times 4, right? Can write it like this. We just separated it. Everything we separated. So into root 3 into root 2. You can write like this. So as you can see, we can simplify it more. 5 times 4 makes 20. And now the thing is, when you multiply these two surds, can you remember previously I wrote something like this: square root AB can be written as square root A into square root B, right? So vice versa, we can write it from the opposite side also. Like root A into root B gives root AB. If you use the same theory here, root 3 into root 2, I can write it as 3 times 2, right? 3 times 2. Then I can write the whole thing as 3 times 2 is 6. Simplify. So I simplified it. 5 times 4 is root 20. 3 times 2 is 6. So you can skip this step. you can write this one and directly come to this one. Okay. So I'll give you 1 minute. Just note this down quickly. Okay. Now we are going to learn about another example. So in this example, previously we multiplied it. Huh? Now we are going to divide. Let's see. Okay. What does this means? That means 3 over square root 20 should divide by 2 over square root 5. Or else we can write this as 3 over square root 20 over 2 over square root 5, right? 2 over square root 5. This is basically this is what they are asking. Okay. So we can write this in fraction format like this. Division means we are going to divide this number by this value. Just consider like this. 10 divided by 2. 10 divided by 2. Maybe. Okay. So first thing, if you write like this, then you can see a clear image of you can uh, take convert some third, entire third into a thirds. So take 20. You know, 20 can write it as square root 5 times 5. Sorry, square root 4 times 5. That means square root 4 comes out as 2 and leaving square root 5. A third, right? Basically, it's a third. So this can write in here, this place. How do you write this? 3 times root 20 over 2 root 5 is equal to 3 into 4 times 5 over 2 times root 5. Okay, got it that right? Then you can see this root 4 is perfect square number. So this can convert into 2 and leaving our third root 5. Then again root 5. We can cut off, right? This one and this one. There's another one also we can cut, but on top we have root 5. See? On top we have root 5 and bottom we have root 5. In the numerator and denominator you have root 5. That means what? We can cut off each other. That contain the same value. These two root 5s contain the same value. So we can cut each other and put 1. That means here this one also 1. 2 divided by 2 is 1. 2 divided by 2 1. Then 3 is the answer. See, if you see these questions are pretty hard or like something like that, if you solve and you will get a simple answer. So copy this down quickly. Okay. Now, there is a special one. Not addition, not multiplication, not division, not subtraction. Uh, express 3 root 2 as a fraction with integer in the denominator. What they are telling is just consider 3 root 2. They want to express this as a fraction with integer. That means a number in the denominator. Denominator is this one. They want you to put a denominator instead of a third. How do you do? Actually, this process we call as rationalizing. You can note down these. These are very important because these terms, these words and terms, definitely will given to your exams. So they will ask you rationalize denominator. Rationalizing the denominator. That means you are rationalizing. Okay. So these words you write. Okay, rationalizing the denominator. So how do you rationalize the denominator? Here, there is a way without disturbing the value. If you just consider this 3 root 2, there should be a value, no? So without disturbing the value, we can just put a number there. And what is that number and how you do it? I'll explain it right. You can put it like this. Consider you are going to multiply a number which is a root 2 divided by root 2. If you cut these root 2s, you are multiplied by 1. That means you are end up with same number. That means if you multiply root 2 by root 2, this does not affect the value of this number. Okay, this does not affect. So you can put root 2 and root 2. 3 over root 2 into root 2 over root 2. Now what happens is you can write this as 3 into root 2. Can you remember that root a into square root a into square root b gives square root ab? Now root 2 into root 2, what it gives? 3 root 2. We can write the top one, the numerator, as 3 root 2 and 2 root 2. A root a into root b gives root ab. This root 2 into root 2 gives root 4, right? Oh, now you can see something. Root 4 is a perfect square number, right? Now you can write it as square root 4 means 2, right? Square root 4 is 2. Now this satisfies all the things, right? Express 3 root 2 as a fraction with integer and a denominator. Integer in the denominator. So you put root 2 in the denominator, right? So you put the root 2 in the denominator. So this is the answer. Not this term. Then I'll write the definition or the proper way. Then you can write it down, note it down as a short note. After these examples, they are going to do some questions. I'm going to give you some time and you will do it quickly. If you're done, just put us a message in the chat, then I'll explain each and everything. Then the lesson will be over. Okay. Okay. So I'll write the rationalizing the denominator. You can note this down. Rationalize the denominator of a square root b. So this is a command. We can pull a general value, a general number. Right? This a and b can be any number from 0 to infinity. Okay. So then we can write this like this: square root b over square root b is equal to a square root b into b squared. Right? B squared. If you put b squared inside the square root, what happens? It becomes b, right? It cut off the square root and the squared value, and it gives b. So this is basically is called as rationalize the denominator. You can note this down, please. Now we are going to do another example. After that, we'll do some exercise. Now we have the complex numbers like this, different numbers, different sets inside the values. Like 7, we have 63, 53, we have 28. So we have different numbers. So first of all, you have to take a common number to simplify a set. What I meant was, think 63, 7, and 28. Those are the third values now. So if I just write 63, 7, and 28. If you just look at this one, we can write 63 as 7 times 9, right? Then 7 times 1 makes 7. 7 times 4 makes 7 times 4 makes 28. If you just look at like this, that means every third is a third value of 7. That means these are entire thirds. So we can write this entire thirds as thirds. Then I'll show you how to turn this. So first, root 63 can be written as 9 times 7. If you look carefully, root 9 we can write as 3, right? 3 times 3 makes 9. 3 squared is 9. So 9 we can write as 3. And root 7 just comes like this. And if you write 28, square root 20, you can write it as 7 times 4. So 4 is, square root 4 is 2. You know, we can write it like this. So that means actually what we can write is 4 times 3 into 2 square root 7 minus 5 square root 7 minus 8 times 2 square root 7 will give you the same thing, right? 4 times 3 into 7, verify how 4 times 3 comes. This is the 4. So I just took it right here. And 3 square root 7 is what? Entire set 63 is this one, 3 root 7. And 5 root 5, minus 5 root 7. I just directly write it down here. And minus 8 is this one, is this, into square root 28. I can write it as a third, not entire third. Now it write as 2 square root 7. So it is 4 times 3 is 12 square root 7 minus 5 square root 7 minus 16 square root 7. 12 square root 7 minus 5 square root 7 minus 16 square root 7. Now you can add and subtract. 12 minus 5 is what? Minus 7, right? Minus 7. Plus 7. 12 minus 5 plus 7. From plus 7 minus 16 is 9. Okay. This is the answer. So you can note this down quickly. Okay, before go to the questions, I would like to do a small, not a small, a similar question that we face in these exercises. So I'll just do that one also right now quickly. Okay. 2 root 6 over root 2 plus root 75 minus 3 root 12. Okay. The first thing you have to do is what? First thing, you can't keep these denominators as root 2, root 12. Those are ugly, very ugly. So we can't keep. We can keep it on only in the numerator only. Something like that. Okay, something like that. Don't keep surds or square root values in denominator. It is very ugly. So in that case, what we are going to do is first we are going to rationalize the denominator. So root 6 over root 2. I will rationalize the denominator. So how to rationalize? I told you, take the root value, this root 2, multiply by the numerator and the denominator itself. Now 2 into root 6 into root 2 over root 2 into root 2, root 4. And as you can see, this is in the form of root a and root b. Root a into root b, that is root ab, no? 2 times root ab, 6 times 2, 12. Okay. So this one will be root 2 into root 2, root 4, and it will be right as 2. So I can just directly tell what will be this one then. This will be like this, root 12. Wait, root 12 also can be written like this, no? What? Root 12 can be written as 4 times 3. 4 is a perfect square number. 6 and 2, you can't. This 6 and 2, those are not perfect square numbers. But when it comes root 12, I can write it as root 4. Because, sorry, 4 times 3, because 4 is a perfect square number. Then this 4 comes out. Keeping 2 root 3. That means this entire thing becomes 2 root 3, right? This entire becomes 2 root 3. Then I'll write like this, the second part, the other one. Root 75. I can write it like this. What makes 75 with a perfect square number? 25 times 3. Yes, 25 makes 5 now. 5 times 5 is 25. So 5 makes root 25 and root 3 comes here. So 75 we can write it as 5 root 3. What about the last part? 3 and root 12. This one we need to rationalize the denominator. So we will rationalize the denominator like this. Before rationalizing, I can see root 12. No? We can just change it like this. No? Root 4 times 3, right? Because it's root 12. So 3 makes 2 into root 3. 3 over 2 into root 3. Why this root 4 becomes 2 now? Root 3 directly I just took it right this. Now we have 3 to root 3. Now I told you rationalizing meaning you are just removing the ugly things. That is the third. So we are not multiplying by 2 root 3. We are just multiplying by only root 3. Okay. We are multiplying by root 3 only. Now you can write it like this. 3 into root 3 becomes 3 root 3 over 2 into root 3 into root 3 become root 9. Or else we can say 2 times 3. And this 3 and this 3 cut off, right? Ending up 3 over root 2. Now we got first term is this one, second term is this one, third term is this one. Now we'll see writing those things in proper way. I'll just take this here. 2 root 3 plus root 75 is 5 root 3 minus root 3 over 2. Root 3 over 2. So I can just write like this. 5, you can just say we'll write 5 root 3 plus 2 root 3. We can write it like this. No? 5 plus 2, it's 7. Root 3, it's keeping the third is doesn't change. And root 3 over 2. Okay. If I just making this a common denominator, I need to multiply by 2, right? Root 2. So root 7 times, sorry, no, by 2. 7 times 2 makes 14 root 3 minus root 3 divided by 2. 14 and root 3. Root 3 actually it is 1 times root 3. No? 1 times root 3. That means you have to subtract 14 by 1. 14 and 1. That will give you 13 root 3 divided by 2. And this is our final answer. Okay. So these are the questions you might get in paper 1, mathematics 1, part A. Okay, so I told you there were some like MCQ types questions. So we don't actually in mathematics we don't have MCQs. Basically it's something like this. I'll show you. If I share my screen to PDF. So in this paper, they will ask you something in these kind of questions. Okay, part A, simplify. See, you have something like simplify. This is binomial. Sorry, this is algebraic expressions x and y is negative. So just like that, they will give you third question. So third is not the entire question in part 2. Okay, you can't expect a third as entire question. It is just a part of small question. So I'll share my screen again to write that note it down. Note this down quickly. The thing is, you have to convert all the thirds into rationalizing. You have to first, if it is something like those thirds are in not in rationalized way, you have to rationalize the denominators. Then you have to take out the common. Like if you can see root 12, you can write root 12, this root 12 as just as like that. But if you convert into another third, you can see these sets can be simplified more. Because the second term, it is end up with root 3, 5 root 3, 75 is 5 root 3. But if you keep it the first term as root 12, those are two different terms, two different thirds. So, and the thing is, you have plus and minus, it's not multiplication. That means thirds are not multiplied. So, to add, that means our first example. If you have to add thirds, then you have to have the same third format. If it is root 3, then you have to keep all the third value in root 3 format. unless you can't add. So I'll give you another 1 minute, copy this down, then we'll do some examples, exercises, sorry. Okay. Now, now you can go to the website and there are some attachments. Or else I'll just put this, put the attachment into the chat also. Uh, this is from exercise 1.3. Exercise 1. Okay, I'm going to give you some bit of time to do. Or else I'll just put this here also. I'll upload it to the chat as well as I'll put it here. And I'll give you 5 minutes. Those are simple ones. Those are entire cells. You have to make it into, convert into a third. Okay. So, and the exercise 1.3, question number 2 is this one. Do these questions quickly. I'll just put this into the chat. Okay. So first question is convert the following entire third. So these are all, everything is entire third and into thirds, like something like, if I just, as example, if I just write it now, if I just take the root 20, this first one, root 20, we can write it as 4 times 5, right? Try to make the square perfect square number inside. Otherwise, you can't make it as a thirds. So root 4, you can write it as you don't need to write all these steps. Okay, so root 4, you can write it as 2 root 5. 2 root 5 is the correct answer. Okay. So just like that, try to do all these questions. After that, I'll give you 5 minutes because we have a little bit of time, so I'll be able to do more questions based on the today's lesson. So I'll explain each question and how to do the answers. You can take it down, write it down yourself. Then in that case, write it quickly, write the answers quickly. I'll give you 5 minutes. I'll give you another 1 more minute. Do it quickly, then I'll discuss the first one, first question, because we have little time. So I'll give you another 1 minute. Shahim, do you need more time or shall I start working out? Okay, then I'll start. So I'll just keep this here. Here, our first question is root 20. We can write it as square root 4 and root 5, right? So square root 4, we can write it as 2 root 5. So this is the answer for first question. So I'll write the answer here also. Now second question. So these are everything is entire sets. These everything is entire sets. You have to convert this into sets. So root 48, I can write it as root 48. What? What are the factors of root 48 that you know? Very easy one is 16 times 3. You can write this as 24 times 2, 12 times 4, but you don't get any perfect square numbers, right? So 16 times 3 makes a perfect square number. Sorry, 16 is a perfect square number. So we can write it as 4 root 3. 4 root 3. So I'll write the answer here. Then what about 72? 72. To find these things, you can just divide this by 2 like that. 36 divided by 2, 80. Just like that, you can go. But if you just uh, look at this, then when you divide by 2, you'll get something like 36. 36 is also a perfect number, right? This is also a perfect number. What makes 36? 6 times 2, 6 times 6 makes 36, huh? So I can write 36 as 6 outside the third. So 6 square root 2 will be your third. So this one I can write as 6 root 2. Then what about square root 28? 28. Square 28 makes 14 times 2. You don't get any value, any of these perfect square numbers. 14 and 2 ain't perfect square numbers. If you go further, you can go 7 times 2 times 2. 2 times 2. That means 7 times 4. You can skip these skips, okay? 7 times 4 makes 28. That means what? 4 you can write it as 2, right? Outside the third as a number. 2 root 7 will be the answer for square root 27. Root 7. Root 7. Now, 80. Square root 80. 8 times 10? Yes, can do. But it does not make sense. So, you had to find square root 4 times. Yes, 4 times is good. 4 times 20. 20 is also a square root number, like a perfect square number inside. 4 times 5, no? That 4 times 4 is 16 times 5 makes 80. 16 is a square number. So what we can write it as? 16, we can write it as 4 square root 5, right? 4 square root 5 is the answer for square root 80. Now what about 45? It is easy now. Why? 45 makes by 9 times 5, right? If you write 9 directly, you know 9 makes 3 into 3 makes 9. So 3 squared. 3 squared makes 9. That means you can write 3 outside and write 5. You can directly take the answer as 3 to the power 3 square root 5. And 75. We have 7 square root 75. We can make, we did this example. So I thought of it. 25 times 3. 25 times 3 makes 75. 25 makes by what? 5 squared. That means I can write 5 square root 3 and like 5 outside. And square root 3. 5 square root 3. Okay. 5 square root 3 is the answer for 75 root square root 3. And what about, sorry, not this one. Square root 147. Square root 147. What makes 147? Does it make from, if you just use square numbers, 4 times something? No. What about, uh, then we have 9 times something? 16 times something? What about 25 times? 36 times? No, then 4 times? It makes like 4 times 3, yes? 4 times 3? 147 is made from 49 times 3. You know 49 is square root of 7. So you can write it as 7 square root 3. The answer should be 7 square root 3. Okay. Now we are done with convert the following entire thirds into thirds. So you can write this down. If you are correct, just put correct tick mark. And if you are wrong, then write the correct answer. Later do the working. Okay. I'm going to do the second question. Yes, I'm going to give you some homework. Convert the following thirds. Now these are thirds into entire third. Entire third. So how do you do that? You have 2 square root 3. Now I told you, first take the outside value of option value, multiply it by itself and multiply the third number. 2 times 2 is 4. 4 times 3 is 12. Answer is square root 12. First answer is square root 12. Isn't this easy? These are the questions. These are the, like, if you know these things, you can easily work out the questions that you are getting for the exams. So this is all your question. We are doing. Okay, first thing what you have to do, you have to multiply the number by itself and multiply the number inside the square root. 2 times 2 is 4. 4 times 5 is 20. The answer is square root 20. So that one easy. Next question. Square root 7. Square root 7. Oh, sorry, 4 square root 7. 4 square root 7. 4 into 4 multiplied by the square number. 4 times 4 is 16 times 7. 16 times 7 is 1. Yes, 112. 16 times. This is the answer. 4 square root 7. Then last two questions. 5 square root 2. That means 5 times 5 is 25 times 2. That is 50 square, right? 50 square root 50. Then last question. 6 square root 11. I told you first you have to multiply by the itself and multiply the third number. 6 times 6 is 36 times 11 is what? 1 times 1, 6 times 3, 6. 396. Right? Answer for the final answer is, if you write it in entire third, it will be 396. Okay. So this is exercise 1.3 and we have 1.3 question number 3. We have, yes, question number 4, 5, 6. Those are for your homeworks. I'll send it to the chat. And also if you are in our website, you can get it from that also. Later I'll just post some put some attachment also for the exam practices questions. So then you can copy this down, then we can finish our class today. You can write the answers, and if you are wrong, If you're correct, just correct it. If you're wrong, write the answers later. Do the workings. I think Sachin left the chat. So I'll end the meeting today.